let's add the shadows. So the shadows are simple. I mean, the basic shadows we're going to be doing because they're just the way your objects interact with light in one way or another. Real shadows can be problematic because when you do the real shadows, we would need to do a lot of ray jumping all over the place, and those shadows would then be either softer or harder. Right now, we're gonna do a simple approach, which is quite directional and linear in a sense, where you're gonna have a light. Let's say this is light. Let me see if I can search for sun or something like that. Yeah, there is sun. That's awesome. So let's say this is sun. We're gonna kill these rays. I'm gonna keep this awesome plane just because we have it now, and we're gonna have this object over here, which is our sphere. What is a shadow? Well, a shadow is nothing but this ray of light going from this sun, hitting this sphere and not propagating further, obviously, right? So how do you know if you're rendering a surface, if you're going to display a shadow surface or you're going to display a full surface? Well, let's say your camera is somewhere or somewhere over here. Let's say that's the camera. Let's see if we have the camera icon. So we're all going all in. Oh, we have the camera. Nice. Camera, nice. So this camera is looking at the scene, obviously shooting rays, and it at some point it hits this part of the plane here. And this part of the plane obviously has some shadow, or I think I drew it correctly. Why? Because this sun that shoots from, it's a point light in our case, so it shoots here and it definitely lights this part. I mean, you get what I mean already, but this is how it should work. Or actually, if it's point light, it actually goes like this. So this is a horribly big shadow that it's drawing. So in theory, your camera, whenever it shoots any of these areas, any point in this area over here, it will be shadow. And everything outside of these 2 points, or not points, but outside of this area, will not be shadow. So what we do now, we're gonna take for each pixel or each intersection we do, when we decide, oh yes, this is the thing we're definitely going for. We're also, instead of just taking this final color as we have it here, over here, we're gonna mesh it up with the shadow logic, so we actually get the shadow in the color calculation as well. It's gonna be a different final color that will depend on shadows as well. So that's the whole logic behind it, is pretty much that. So if you go back here, let's say we hit this point over here, that's a shadow, right? So I don't think this is also any sort of a philosophy going forward, so I might as well copy the calculate shadow function, because it would take me a bit too much time to write it, and you will probably just move the move the video until I finish it. So this is the calculate shadow function I wrote for calculating shadows on any pixel you hit, pretty much, and the whole logic is exactly this. Wow, in inverted colors. This is the whole logic of it. So let's go through it. Ignore these for now. We're gonna go through, obviously when you hit the pixel, let's say you hit this plane over here, obviously you're gonna need to see which objects you are hitting when you go towards the sun. So if I hit this point over here, what I want to do, I want to shoot a ray or rays, depending on how much lights you have, how many lights you have. I want to shoot the ray towards a light source, whatever I have, right? And in this case, I'm going to have this one. And the algorithm just says, oh, go shoot the ray towards the sun, towards the point light. If you do happen to intersect with an object while you're doing so, that means I'm in shadow. That's pretty much it. So here, if you go back into code, you go here and you need to go through all objects again for each of these points, and you say, yeah, am I intersecting a sphere? Yes. My final color is gonna be not the color I want it to be. It's gonna be some educated guess color. You can check the code later, I'm gonna leave it. But anyway, this is an educated guess color that just darkens the surface a bit, so you can get the shadow feeling, nothing special. There is a way to get better shadows, but it's definitely not in the scope of this tutorial. And it's getting pretty long now, more than an hour, and yeah, it's it's a lot of time. So the thing you do here is that you don't want to intersect with yourself when you're doing this, or maybe you even do want to do that in some cases, but we do have func shading that handles a lot of these things over here. So for now, let's ignore our own objects. So if you are the sphere, and let's say we hit the sphere with something, we don't want to send a ray towards the light, let's say a point like this, and then when you send it, you hit yourself, and then you're like, yeah, I'm shadow. Sure, you are shadow, but the func calculation kind of gives you something, and you can definitely add shadow. So but we can play with that later on. Anyway, that's the whole algorithm. As I said, you shoot a ray towards the light, you hit something, you're in shadow. This is what we do here. If I compile this, I will have problems because I also have this this whole logic that I added with the type and the index that I pass to this one to know which one is me when I do this shadow calculation. So we will define two types that will be sphere equals 0 and define plane. That's gonna be 1, and then we're gonna see what else we changed. I think we might have changed the intersect sphere function. Did we hit shadow rays spheres I distance shadow surface normal? Oh yeah, we're doing the intersection part over here, so we can feel free to move the whole intersection part above the lightning part, because it kind of makes sense. So let's say we go gradual from something super math specific to something a bit more high level, and then lightning and so on, so it has some sort of a flow to it. So we place the intersect plane. Yes, we also changed the plane. We have this p hit right now, so we can do this. Okay, and now let's try using this shadow function. So shadow function takes a p hit, that's the point you hit. Let's say you hit the plane, final color, in out, so you pass it and it goes out as well. This can be just out, to be frank, or oh wait, maybe I am using it. No, I'm just setting it so I'm not using it. It's gonna be an out one. Ambient is the ambient is the ambience of the material of the thing you just hit. So depending on how much ambient light it now takes, which is part of the func shading model, it will display that amount of light. But I mean, if you do this properly, then you should get this light by kind of shooting a bunch of rays all across the place and figuring out how much light you get. But this is a simplified version and it works fine. Type and index are over here. So when we do the final color calculation, we're gonna do some more magic with the shadows part. Let me see what I did here. Yes, so I get the color, then I do the shadow calculation like this. So here, when I get the color, I get the shadow color. So I pass this one, materials, sphere 1, That seems to be fine, and then we can do this as well. Planes, material. And this is obviously a plane now. Cool. So you see, simple as that. There are shadows in our scene. Okay, now we have shadows. I don't think these things are super important to go deep into, but I did explain how it works in the gist of it, so go through it on your own. There's also this scenario where we cover an edge case where your light and camera are positioned in a certain way, and you don't see this manifestation right now because there is no reflection whatsoever. I'm gonna zoom in so you see how beautiful it is for now. I do hope you like it so far. Also, you'll see that the lines, there is no anti-aliasing implemented, so you're gonna see that as well. Maybe we can do that one day as well. And now let's do the thing after an hour and a half or something. Let's do the thing, the thing that actually caused this this whole revamp to be done. We need to do a main ray tracing loop, which will do all of this in a way that you bounce a ray, and that ray keeps bouncing around. So if I hit the sphere, it might be reflective, and then I basically shoot another ray from it, and then I shoot something else, and that thing might be reflective. So I shoot another ray, and then that thing might be reflected. And that's like a kind of a recursive way of shooting rays all over the place. That's how ray tracers basically work, and they can go up to a certain depth. And then depending on the properties of the material you hit, you can either bounce a ray or not bounce a ray at all, or the ray might bounce or reflect and refract at the same time. And then with that loop, you get the basic logic in, so you don't need to worry a lot about how you go level per level, if you know what I mean. With the last implementation we did, the implementation was super specific. I wanted to show you how you, I don't know, intersect with a sphere. And then I wanted to show you how reflect. And then I wanted to show you how you refract. But the way we did it sequentially, video by video, the implementation we did was not super friendly to this approach. So we're gonna do that now. And the way you do it, we're gonna need to have one big loop inside of our ray tracing code. So we're gonna loop like this. So we're gonna do this bouncing several times. Now if you do this, of course it's not gonna compile, and even if it compiles and runs, it will do something weird here because we're missing a lot of logic to make it work, and I'll explain in just a moment what we need to do. Or actually no, it's not doing anything weird. It's not doing anything weird because we're just doing the same thing 2 times. But we gotta twist the logic, right? So I started drawing something here that didn't make sense. Can kill that. And let's switch to this view. What do we want to achieve with this loop? Let's say you have this, and let's say you have your camera, and let's say you have, I don't know, a bunch of other objects, something like this. Let's say you shoot a ray like this, and it's the first bounce, as I call it. It's the first ray that we shoot through the canvas originally, like the original ray. This ray over here, or I might as well make it here, it shows this this sphere. This ray might bounce back, be reflected in some angle. It can be a perfectly round sphere, so you get the same angle. It might go somewhere like this if there is maybe some diffraction on the surface that makes it go like that. You might reflect almost nothing, so your ray kind of loses intensity or power in some way or another. Or you can go and refract into the sphere because it's translucent, and then it breaks, and it breaks here as well. You know how it goes. And that's the thing we want to do. So we want to do loops, and it loops like this original ray. Then we're going to do reflective ray. So we're gonna do whenever you hit this object or plane or sphere or any other object, we want to bounce the ray from that object onwards, and that's the next loop. And then if you have 15 bounces, the ray should keep bouncing around the place, and combining the colors it hits to some extent. And the way you will combine those colors, it depends on the original material you hit. It depends how much of the other color you're gonna borrow, and we're gonna like fake it to some extent. Again, I mean, all of this is faking in a good way, but we're gonna fake it so it looks okay, and then later on we can do the real stuff with Fresnel and other equations. Okay, let's go back here. So what's the thing we want to do? As I said, we have the original ray, and then we want to bounce that ray from the surface somewhere, depending on the props of your object, right? So let's take it step by step. So if you have a sphere that you hit the sphere and it's closer than the distance, fine. This is a good candidate for the final color. The thing we also need to introduce here later on is we're not going to have a final color. We're going to have a pass color, and then we're going to do a lot of these passes and bounces, and then the final color will be some sort of a combination of those colors. Let's say we do a one pass, and let's say when we do one pass we output the final color outside. We have that scenario. Let's say we have two passes. So the first time we hit, we do this. The second time we hit, the second time we bounce the ray origin and ray direction obviously change. Now the ray origin is the place where you hit the object you hit, right? And the ray direction is the normal of the surface you hit. So that needs to change. So we can do that. We need to store the ray origin and ray direction throughout this whole thing over here. We can't just replace them, but what we can do, we can do so each bounce we need to change the origin and we need to change the direction. And maybe I was thinking maybe we should have a separate variables for that, but I don't think it's actually necessary. We can just do this. Ray direction is gonna be something, and the ray origin is gonna be p hit, because that's the point where we hit this. Direction is gonna be, we're gonna reflect from a surface in this scenario. Like, let's reflect. It was the incident ray, which is ray direction, and it's gonna be surface normal. Okay, we're getting some things. It definitely looks looks interesting. It's definitely not correct either. But let's inspect what's happening. The ray origin, we are putting it to hit. This one is reflecting against the surface normal. It might be that the direction, we definitely need to, I'm not sure if reflect does do normalization in this case. It seems it does. So we're gonna move that away. It might make sense. It makes sense because this one was normalized as well, and this one was normalized. So we shoot that ray instead, and then this one will work fine. Object hit distance is definitely not okay, because object hit distance needs to be per bounce. Yes, and distance over here also needs to be per bounce, because it changes. Each bounce you do, it should change. And now we see this kind of behavior. I mean, it's weird that we can see our own sphere over here, so I would assume something weird with reflections happen. This one definitely reflects the sphere. Okay, so now we get this weird behavior, and we definitely don't want for it to look like this. Now it looks weird, and we also have intersections with ourselves. the first thing we've got to do, we got to check if we are actually intersecting with ourselves. So when you do the first bounce or bounce 0, you will hit, let's say, a sphere, and then when you do the second bounce, you should hit I don't know, you should hit a plane. For some reason we seem to be hitting a sphere over here, which I will not go into right now, as it's been it's been already almost 2 hours of recording, so we can go into it maybe in the future, but I do know that for sure we need to do the elimination of ourselves from the equation anyway, because we will have problems with the different kinds of artifacts popping up here if we don't have that right now. Also right now we are calculating final color based on the last bounce we do, which is just the second bounce we do over here, which means that this is what the second bounce sees in the world at this point. For that, we first need to get rid of ourselves and say, yes, I'm hitting myself over here, or actually in the previous bounce I had myself here, so I don't want to do this right now. So we need to have a way of tracking this. So we're going to have previous type and previous index. And then we're going to say, when we do this, we can say here the previous type is sphere. So we intersected with it, so we say, yeah, this is our previous type. So the next bounce will be aware of this being hit in the previous iteration. So we're gonna do this, or sorry, I. We can do the same thing over here. Plain I. And then let's say we're looping the second time. When you're looping the second time, you can say if the previous type is equal to sphere and previous index equals I, and continue. Because I don't want to, when I do the bounce, I don't want to intersect with myself. I want to intersect whatever is around me. When I do this, you'll notice that I can see only the red one in the blue, in the red one, and blue one in the blue one, or the red one in the blue one and blue one in the red one, because they're reflecting each other. The planes might be seeing each other at this point, but since the view is quite broken at the moment, we don't see it. We will anyway do this, and I realized that actually we need to do this here. Yes, this one is important. So I don't think we should be seeing major changes with the planes one. Yeah, we do see something. It seems that that's the reason. Might be, might not. It's definitely wrong. Yeah, finally. Okay, this makes more sense. Oh, that scared me. So now we have that, and now we need to kind of blend all of these passes into one pass. The way you did it, you usually add those colors on top of each other, all the passes you have, divided by the number of passes you did, so you get the average color of some kind. Also, there is some weight factor there as well. Like it can get quite complicated. In our scenario, we can just do a basic thing. We take the base color of our base object, and then we add on that base color object, we add more colors, blend them in some way, so they affect how this thing looks like based on the specular component of the thing. And for that, we're just gonna do a simple thing over here. First thing, we're gonna replace the final color, and we're gonna make something called pass color. And pass color is the color of only one pass over here. So each pass will have its own final color, obviously. And then the final color should be kind of the addition of all of them, although not really. So if you do just final color plus equals this one, we'll definitely have weird stuff happening. Or not weird, but the color will not be super correct, or it will look too bright, possibly, which we will need to decrease. The pass color over here, if we don't hit anything, well, it will also be quite problematic, but it's fine, we can live with that. So final color, let me see if we are using it. Calculate shadow. Yes, we're using the final color for the shadow, so that needs to be removed. Yeah, compiling is definitely significantly longer. So we are getting something now. It's also interesting how these reflections work. It's I would say it's not something I would expect to see, to be frank. I mean, in theory, if you do this, then you do the right math. Oh yeah, it's the other way around. Okay, so now we're getting something. I definitely don't know why we are seeing this sort of thing. I can also instantiate this prehit to ray origin, just for some sort of consistency. So the surface normal is not being set here. Which is something we should probably start thinking about. We need to unify this. So we might burn ourselves many times with the surface normals in the future, because it can get quite confusing. Okay, so now what is happening here? Oof, there is also this thing. There's this thing that is definitely problematic. That's the first thing I see. Surface normal is also something that should be calculated here. And p-hit should be, every time we do it, we would like to have this thing here, maybe like this. So we can also just do this. Might be that if we do some weird intersection, we don't. Yeah, final color. Final color is actually not okay here. Yeah, there is one. I think I found the mistake. So here. We set the previous type immediately, so this is definitely not the way we can do it. We should have a type that we have currently, int type. So in this pass we have this type, right? Int previous index equals -1. So here, not previous but index. I'm getting tired, it seems. So we're gonna do this, we're gonna do this. And then after all of this is done, we say, well, this is the thingy that was in the previous one. So previous type equals type, previous index equals index, and we fixed it. The thing we didn't fix though is what the heck are these? So we're gonna do this thing for sure, so let's try eliminating stuff. If we're bouncing like this, I wanna have this, I wanna have this. Because on the first bounce there is nothing to blend with, but the problem is we still have no idea why our next iteration of bouncing produces these kinds of weird artifacts, because that's just simply wrong. Okay, so this is weird. So our surface normal and p hit are not defined. If we do not intersect with anything, let's say this area doesn't intersect with anything, we will still do the second bounce, and when we do the second bounce, we're gonna use whatever we set here. Yeah, exactly. So we're gonna use whatever we set here, and we're gonna intersect with that. Yes, I mean, in our case it doesn't matter. If we do have planes, it should work fine, but I wonder if we don't manage to intersect here, we should not be doing any bounces. So let's do a boolean that says false here, and then we can, in theory, if the type hasn't been set, I mean previous type, this also needs to move in. And previous type needs to be persisted, that's fine. We can actually then say if the type less than 0, break. Yeah, there you go. Now it's not intersecting with that thing. But the problem I have in my head still is that if we do return, if we do put this back here, and this one says that there are planes, of course, but we need to do this as well. I wonder if these artifacts are gonna return. Good, they're not returning. Yeah, this one also needs to be removed or changed. now we have super weird behavior, which is even weirder that we had before. But this is plainly a problem on this plane level, pun intended. So we can sort that out in this call over here. Let me see, the p hit, we get it here, it should be fine. I mean, in theory we could return p hit here, so we see what sort of what we actually get here. But let's for now just try to quickly glimpse over it. Maybe we see the problem. It's not the shadow, I don't think so. Yes, the shadows look actually quite correct, but this doesn't look correct. I think I put I think I did something stupid here. Yes, exactly, I did this. And p hit is now officially not set to anything unless we do this. We can do this. Reorigin equals p hit, and p hit, you can actually put it here and say what? No. Say this is super weird. This doesn't make any sense. Intersect sphere, does it do with anything with the p hit value? No, it doesn't do anything unless it's true, which means that if this is false, this won't be modified at all. Same goes here, I think so. Oh yeah, exactly. So we need to do this if, so we need to modify the value only if this t is true, and then do this as well. So yeah, the logic changed a bit, because we put this p-hit thing on the signature of a function, and this still doesn't do absolutely anything. So yeah, p-hit should be set, and we don't need this. Yeah, there's one big problem. One big problem here another bug that I made. This p-hit is the p-hit that we're changing, and it's changing every time if you intersect with something. But it doesn't necessarily mean that that's gonna be the p-hit from where you start from, which means that we need to set the p-hit here. 3 pass p-hit. And the reason for that is that if we set it inside of this, that means, yes, this is the shape, or this is the element I want to draw, and this is its p-hit. Surface normal, we gotta do the same thing with that. And I think while I was mumble jumble debugging it, I did it here. I also did this thing over here. Surface normal is something that yeah, and this one we don't need. We don't need this, it's just p-hit. And pass p-hit is the one we set here. Yeah, now it looks much better. Yeah, and now let's, yeah, so this was a fun debugging. I in the final edit, I'll probably speed this up, or actually you already saw the sped up version. Just to quickly brief you on what happened, nothing particular. In particular, the bug was actually the fact that this p-hit was being passed to these functions, and then p-hit was changed internally in these functions. And we kind of stored every intersection that was true. We stored the new p-hit for a position for those, which is not the thing we want, because sometimes it might happen that you intersect with something and it's behind something, and then you don't hit this condition, but you still change the p-hit, and it's a sneaky bug. It's mostly to the fact that we kind of went too fast through this, but at least you know what to do when you're gonna do it yourself. For now, I'm gonna also remove this comment have wrote. We don't need it. So yes, intersection and bouncing, right? We have 2 bounces right now. You can see that it's 2 bounces because this one doesn't have reflections on it. If I said 3 over here, weird things will start happening because there will be more bouncing, and now you're bouncing from this to this to this, and all of this is super reflective. There is no diffusion of any kind or any sort of loss of the reflection as you go. And in theory, if you placed 16 or something like that here, it will look like this. So you can actually do quite fun effects with this. Yeah, look at this. You can get really fun things because you get a lot of reflections all over the place. For our scenario right now, before we introduce Fresnel and such things, we're gonna stick to 2. And also the thing we're gonna do, and we definitely need to do that because without that we just get full on reflection right now. We need to do some sort of material specularity. So depending on what you hit here, your ray is gonna bounce more, or actually you're gonna get more or less color from whatever you're refracting. And I made a small function for that in the implementation, so we can put that in the utils now. And I will explain what it does. Basically, it gets the material of the thing you hit based on the type and index. So when you pass sphere 1, you're going to get the right index. Why we need that? Well, in this final color calculation over here, we might want to, when you get the final color, or the pass color, we want to do something like get material, or what was the name, or get material, yes, of the type we currently are hitting, right? It's not the previous type, it's the type of the current bounce. So let's get the type we hit, and we can, by the way, we can do the same thing here, so maybe we can remove this, but let's see, this and index is the current index, and we're gonna get the I think we need to get the ambience, or not the ambience, the specularity, maybe. I think it's specularity that I went for in this approach, and I think I did some more. No, I didn't do any magic there. So it's a specular, which is the kind of the reflective component. And when you do this, you get this. The reason why you get this right now is that we're just adding stuff on each other and then doing this. I think if I do this, it will get even brighter, to be frank. Yes, I think we can safely ditch this part. Yes, and now we can actually put this part. Yeah, so we're getting something. I'm not quite happy. Oh yeah, oof, that makes it quite different. So you take the color and you need to multiply it by the specular component. Now we're getting this. Let's make the intensity of the light a bit stronger. Maybe that will help in our scenario. Yeah, okay, let's make it even brighter. Okay, it's doing something. It's doing something. I'm not sure. This is the thing I want. So in theory, we should take the. Let me think. If you get the material of the first one, you take the specular, and you multiply it by the pass color. Yeah. We definitely need the bounce. If it's the first bounce, this is your material, so you're gonna do this, therefore full-blown color, and then if it's not that, remember all of this is just faking it to look nice pretty much at this point. It can be exact science if you want to, but for this purpose we just make it nice and fake. And we're gonna this 15 again, maybe 25, maybe 35. Okay, so you can see that it is doing something. We have reflections and stuff. I want to put this sphere back again because it's a bit too far. I don't like it being there. There we go. It's already better now. So this implementation, it turned out to be slightly different than this one because the way we do some calculations in the original one that I made is different. This is actually more correct, the thing we did now. It has 2 bounces only, so you can't get more layers of reflection. If you want to, you can't do that, but then you just get weird reflection all over the place, and we gotta play with that logic a bit more to make it feasible. So this is the final code for the tutorial. It was a super long one, and there was a lot of back and forth at one point, but I will speed that part up, and then if you're interested in what I was doing going back and forth, you can do. that I encourage that you do some research. But basically this enables you to put as many spheres and planes in the scene you want, and it will do some reflection there. You can also play with materials, so if you start changing the material properties over here, where did I put them, let's say if you want to make them less reflective, you can do this, and then you lose this reflective shininess that you have now to some extent. It's not dramatic because, oh, now it's going to be shiny. It's not super dramatic because we have a lot of work to do to make it as we want to. But yeah, because right now you're just calculating this color and doing stuff. But that's pretty much it for this one. Hope let me know what you think about this format where there's more like dialogue and more thinking and more of me trying to figure things out as I go. Let me know if this is better for you or you like the scripted approach more. But yeah, that's it for today. Next time we're gonna make this code better. That's the thing I can for sure promise. So we're gonna go through it and make it better. We're gonna see if we have more bugs lying around, which I'm pretty sure we do have. Things lying around, and I realized I was changing the raw material here. So yeah, that's pretty much it. Hope you liked it. Subscribe if you want to see more content in the future, but that's about it for this tutorial, and see you next time.